if you can't stand the heat, right?
Excellent. So thank you, everybody. We are sorry for the awkward pause, but we are super excited to be here. We are cooking up something amazing for you today. As you might be able to tell by these amazing outfits that we are sporting for you today, we'll be looking at how you can use Angular 2, the same Angular 2 that you use to build web apps, the same Angular 2 that we're here today to talk about, and native script, which we work on, to build mobile apps that run on the web, as well as native mobile apps that run on iOS and Android, and how you can take this approach and share the same framework and even some of the same code. Now, I am Chef TJ, and as you might be able to tell from my outfit, I have years of experience mixing and matching code to build apps for various mobile devices.
And I'm Chef Jen, and I've created more tasty mobile apps than you can shake a wooden spoon at.
So Jen, what are we cooking up today?
We are going to be mixing up for you today a groceries management app to show you just how easy it is to share web and native code. So the idea is that we can write something once and run it everywhere. We've been trying this for years and it's worked really well so far. However, this is one of the reasons that people are so attracted to Angular 2 plus our integration with NativeScript. You use the code that you've already written for the web and you leverage NativeScript to build for Android and iOS to create a truly native mobile app with no web view in sight.
But this begs the question, especially to a room of people that I believe are probably, how many people here consider yourself a web developer in some way, shape, or form? So I see a good majority of the hands going up. I mean, why build for native at all? Well, if you look at actual data, usage data out there, and this is some data that a guy from Google, kind of well-known, Luke Wroblewski, put out, he says that native and the web each have their own sort of unique characteristics, their own unique advantages. If you look at native, for instance, as this chart shows, people spend a lot more time in native apps, almost 20 times more minutes in some cases. And this is really because native has the potential to build these really rich, really performant, really compelling experiences that native is really known for. But of course, that doesn't mean that you shouldn't build for the web either. The web is known for its reach, or its ability to really run everywhere. The web isn't restricted by device type or operating system. The web runs everywhere, so it's a great way to reach a large and diverse set of users.
So as Luke Wroblewski has said, and this is the quote that everybody likes to pull up on their slides, so we're going to do it for you today, the web is for audience reach, and native apps are for rich experiences. Both are strategic, both are valuable, so when it comes to mobile, it's not web versus native, it's both.
But Jen, if we're building for all three of these platforms, that's really hard.
Oh my God.
We have multiple code bases.
No.
We have 3 different platforms.
No.
There are all these languages
Stop.
and IDEs, and how are we going to keep all these features in sync? What are we going to do?
I don't know, maybe switch the slide. All right, we're going to take this good stuff, we're going to mix it well, and we're going to take an Angular 2 code base, mix it well with NativeScript, and we're going to get Angular, NativeScript, some kind of mashup going on here. Okay, so let's see how all of this works. Today we have a 3-course meal prepared for you. We're going to start with a bit of setup, just so that we can see some of the special considerations that are inherent to building from multiple platforms. Then we'll build up a small native mobile app so that you can see it all in action. And finally, we're going to end with a discussion of strategies for building your own apps moving forward.
Okay, so I'm going to set up into some actual code here. Now, there are many different ways that you could structure your application, web and native. You could use a single code base, you could use multiple code bases, there are various techniques. For today's purposes, what we'll be doing is showing a web app and a native app side by side, just for demonstration purposes so it's easier to see what's going on. Now, what we're going to be building is this little amazing grocery management app here. You can see super complex app where I can log into my application, and eventually here I'll see a list of groceries. Or I will not see a list of groceries. Let's see if I can do this.
There it is.
All right, we're seeing it now. Let me
that green
blow things up a little bit better and go ahead and refresh here, get these things on the left and right hand side of the screen. So simple grocery management app, I can log into this application, and if the Wi-Fi is with me today, I will see a list of groceries. So we'll get back to how that works in a minute. Now if we look at the code that actually builds this up, hopefully the Wi-Fi will come back here, you'll see code that looks like a lot of the code you've seen today for Angular 2 web apps. You see components and these Angular 2 isms. And what we have right now, we've started on a little native app that we'll be building up during the course of this presentation. We'll try to get it to look like this web app over here. Oh, there's the full list that loaded up here. And currently, what this looks like is Hello World. So we'll bring these back up side by side.
Well, let's get started with some mixing, kneading, and folding in the UI. So I see some HTML actually in that web base for the web app. And why don't we just like take a chunk of HTML and like slam it into the native code and see what happens?
Yeah, so if you look at these things side by side, if you've done Angular 2 before, if you've even tinkered with it, you probably recognize most of what you see on the right-hand side of the screen here. Now, the only thing that's going to look different for my native app, for my native script app here, is this label component. This isn't normally how you write labels for the web, right? You write labels looking something like this, where you put the text within it. Now, the reason that this label looks like this is in NativeScript, we are not using a web view. This app here, although basic, there is no DOM here, there is no HTML here. So I can't take these divs and spans, these things that are specific to the browser, and use them in my NativeScript app because there is no H1, for instance, in the iOS SDK or the Android SDK. These aren't things that exist. What we do in NativeScript is we take these components, for instance this label, and we render them with iOS and Android specific code under the hood. So we showed the label here, and I'm going to paste in a little more code just so we build up this app and you can see a little bit more of what this looks like. So instead of using things like divs and spans, you're using things that we can translate into native code, things like stack layouts and text fields and buttons to actually build up your application.
That looks fantastic. It's looking better already. But since we're looking at making the UI look similar on both web and mobile apps, maybe we should take a look at some CSS. I saw some class, what was it called, class fields and that sort of thing. Let's take a look at the CSS and maybe we can share some code on that level.
Now in NativeScript, remember, we are building truly native applications. But one of the things we do provide is a CSS syntax that works very much like the CSS that you use on the web. You can see that the structure here looks pretty similar. You got the import statement, you're selecting things by their tag name, we got some CSS class names, even the name value pairs are similar as well. The difference is in NativeScript, what we do is we actually take each of these individual rules and we convert these into their native iOS and Android equivalent. So what that means is that although you can use a lot of CSS code, you can see like for instance in this file here, and we can also do things like I can do things at the Angular level using things like the style URLs property on this code as well. However, there are some CSS rules that we just can't possibly replicate in iOS and Android land. There's no real equivalent or no real performant way you could make the web's float, for instance, work on Android or iOS. But at the same time, think about the equivalent amount of things you'd have to do in Xcode or Android Studio to style these native controls. It's a lot of mess. And by sharing the same technique, the same syntax, you can get a lot done pretty quickly using syntax that you're already familiar with.
Well, it looks like we do have to make some compromises on the UI to support both web and mobile native elements, though we're definitely able to share some structures, right? So let's move into the real money proposition. Now this I think is actually the amount of code that you can share on the service tier level. So I'm guessing when you click this button, you're going to want something to happen and some sort of call to a backend to occur. So we're going to show you how to share code on the service layer. And I look at the service tier as a roux. Who here cooks? Julia Childs? Oh, awesome. Well, so the roux is the base of 3 of the mother sauces of classical French cooking, right? With a good roux, you can build a bechamel, a velouté, and an espagnole sauce, right? So we start with a solid base, and you create all kinds of greatness on top of it. So let's show the audience how we can share the service tier intact between web and native.
Yeah, and if we take a look back and we again compare our web and our native apps, you can see that so far there have been some differences. We've had to provide different templates for our web and our native app. Our CSS isn't quite the same, but the service layer, as Jen was talking about, is something that you can pretty much share directly between your web and native apps. And in fact, that's what we're doing in this example. If I dive in here, for this example, what we're doing is we literally have a shared folder that we just copied and pasted between these 2 apps. Wow. Now the reason this is possible, and the specific API we're using here is a user service, which is just a little service that we built for logging the users in. And the reason this works, if you actually look at this class, you can see we've written this in a way that isn't tied to the UI at all. You'll see that there's no iOS code here, there's no Android code here, there's also no browser, there's no DOM code here as well. The reason this works is the Angular team has implemented this HTTP service. If you were to look under the hood in the source code, you'd find an XML HTTP request and all the various web APIs for implementing this code. What we've done with NativeScript is we've implemented these same APIs for the HTTP service, but done so with iOS and Android native code to make the same calls. Now, why this is cool is that you as a developer can use this file and you don't need to care about where you're at. This file just works out of the box and you don't have to worry about it. And this is going to work for more than just, this is a simple example that's hitting a RESTful API, but we also have plugins for things like Couchbase, things like Firebase, some of these services, these backend services that you may already be using in your web apps that you can now bring over into your native apps through NativeScript as well. And what this code is actually doing, just to show the code that I pasted in here, all I'm doing is logging the user in, and if things are with us today, all I should see when I get back is a simple success, just for now showing that we're hitting our backend successfully.
Fantastic. All right, we've got our service tier all set up, and it seems to me now that you need to be able to click that button and actually go somewhere, right? You know, alerts on login, maybe not so fabulous. And it seems like for this we need a router, right? So how similar is a router setup between web and native?
So if we move back, let's bring our native and web app over here. If you just think for a moment about routing at a high level, routing sort of by necessity needs to work a little bit different in a native world versus a web world. So in the web over here, you have things like URL, you have hashes, you have a refresh button, a back button, all of these controls that we know and love for the web. In native, you don't necessarily have these things, but you do have different navigation patterns. Like on Android, you have the hardware back button. On iOS, you have the little back button in the top corner. You have the little gesture that you can swipe across to go back. So what we've done in NativeScript, and I'm going to do two things here. I'm going to paste in a little more code, and I'll explain how this works in a minute. But what I mostly want to show is the code where we set up the router on both of these ecosystems, because I think it's really kind of cool to see these side by side component here. Now, if you look at these side by side, again, remembering this is the web implementation, this is the native implementation over here, you can see that to the naked eye, these two look almost identical, right? There's very few changes between the two. Now, what is different, if you've caught it already, is that in NativeScript, we're using a router outlet that we wrote called a page router outlet, which basically just wraps the Angular's own router outlet that provides an out-of-the-box way to do these or take advantage of these native capabilities, things like the hardware back button, such that you get to code to the same APIs. You can see this file is almost identical, but you get the behavior. If I go back to my app here, I can now sign in, and if the Wi-Fi allows it, we'll go to the next page, and then the hardware back button will work out of the box. So we'll see in a second.
Okay.
Go ahead.
All right. Well, we've talked about, let's see, we talked about the UI, we talked about the service tier, we talked about the router. Shall I wait for you to sign in? Or
We'll go ahead.
Okay, moving on. Moving on. We're going to add a little garnish now. Let's talk about some of the pretty details we can add on the native side especially, that we can make to make the user experience really great. What people love about their mobile apps is that beautiful native user experience that looks a little different maybe across Android and iOS.
Yeah, so the Wi-Fi is betraying me here to show the actual login. The hardware back button would work, but I can show one other thing on the login page. Something that we announced in our new NativeScript 2.0 release is that we support now CSS animations that you can write using the same code you'd write for the web and have them work in native apps as well. So what I have in this application here is we've got a little UI component, grid layout that has a class of scale down. And what I'm going to do with this is I'm going to write a bit of CSS code in here that actually takes this class name. And if you've worked with CSS animations before, the code you see here should look fairly familiar. I'm going to give this thing a background image that points at an image within my application. I'm going to do a quick little scale animation. So we just get a nice little background image that scales down as the app runs. Now what's cool about this is not only do you get to use the same syntax that you would use on the web to define your animations, but remember that these animations, when you're running in a native app, are running directly on the metal. Meaning you can push these animations a lot further than you could in the web. And we'll show a few examples of that momentarily.
It's very exciting to see CSS animations that you can use within a native app. That's really, really awesome. This is brand new for us. So really exciting. What else can we make happen on this UI? I'm sure we can have something really useful and user-friendly.
Yeah, so we'll see if we can sign in. Oh, there we go.
Oh,
so
we
there's
logged in.
my harder back button.
Yay!
So just to take a step back here to discuss sort of where we're at, we talked about some of the things that we can share and some of the things that don't make as much sense to share. But one of the things I really like to sort of encourage people is that if you're going through the hassle of building a native app, right, if you're going to build an iOS or Android app, it really behooves you to take advantage of building for those devices. When you're in a native app, you can do a lot more than you can on a web app. You can think differently. You can do different things. So you really don't want to think of your native app as just like another image of your web app. You want to think about the unique things that native apps can do. And just to show like one quick idea, so I know everybody here is going to want to pick up an apron after we show this up. So I'll add this to the list here. One of the things that native does out of the box really well is give you a pull to refresh. So if you were in a web app, to implement that sort of UI, you'd have to bust out some virtual DOM hacks and some sort of hacky DOM code. In native land, it's basically a Boolean, right? You just get to turn on pull to refresh and implement how you want that handler to work. I mean, there are other things you can do as well. Imagine I could make this an endless scroll grocery list. This is quite easy to do on native. I could add swipe actions if I wanted the users to be able to swipe to delete from the list. I could tie into the native share widget that is available on these devices. So it really makes sense to share the stuff that makes sense, things like the services, the models, the data that we showed earlier, but to take advantage of the unique environments that you're deploying to. And so I have one final example. So everybody likes to end with a bang. So to really show that you are actually running on a native app here, right? You're not building on a web app. I want to show at least one thing that you just basically requires bytecode to do, that you're not really going to be able to do on the web. And one of our NativeScript experts, Brad Martin, wrote a NativeScript plugin, and its name sort of is very descriptive, NativeScript explosion field. Basically, you just pass it a UI element, and it makes it explode. It's a very practical, very practical plugin.
Absolutely.
So what I'm going to do is this login function currently is kind of boring, right? It just logs the person in. That is not a whole lot of fun. So instead, what I'm going to do is make a few things on the screen just explode, because that is far more interesting.
Much better.
Now what's cool is that this plugin is actually using a jar from Android Arsenal. So one of the things we do with NativeScript is we also give you the ability to use some of the best things that native has to offer, things like CocoaPods and iOS, jars from Android Arsenal, and to leverage them in your NativeScript app using JavaScript and TypeScript code that's sort of easy to use. So now, when I click this, watch the logo is going to explode here, boom. And then after that, this is going to explode. And then after a second or two, we just make the entire application explode just because that's sort of fun to do. But just sort of wrap it up, this is just the different way that you can think about designing your application. Share code that makes sense, things like services, model, data, but then build the views so you can build the best possible experiences for the users, for the apps that you're building. And with NativeScript and Angular 2, we think this makes a lot of this possible.
It's very exciting. So TJ, I think it's time for my favorite time of day, which is dessert. Sometimes I don't even bother with the meal, I just go for the dessert.
Oh.
Not that one, next one. Yes.
That one, yes.
So what we want to do is just give you this show-stopping cake, essentially. We want to point you in the direction of this fantastic Angular 2 advanced seed that one of our fabulous Telerik developer experts has created for us. Nathan Walker, where are you? He's been there, he's around here somewhere. He has created this easy way to scaffold an Angular 2 app plus NativeScript plus desktop plus Space Station, whatever you need. This will allow you to get up and running really quickly with Angular 2 and NativeScript, and it's really, really exciting.
And the last things I'll mention, so we have a booth right outside. So if you stop by our booth, you can enter to win a variety of prizes. I want to call special attention to this NativeScript, this amazing NativeScript Angular shirt here. If you wear this shirt tomorrow, you can stop by. We have this spinning wheel, which is pretty awesome. It's like totally, it's the
Wheel of Fortune
Wheel of Fortune
or something
style spinner. And we have some pretty cool prizes on here, including some iPad Pros if you're feeling lucky, but you need to wear your shirt to spin. The shirt was in the swag bag today, so if you want to wear it, that would be amazing. You get a chance to win a prize.
Spin to win.
If you are intrigued by what we said, we only had 20 minutes up here to talk very quickly. You can head to nativescript.org. There's a big green started button that'll take you into a little tutorial that'll walk you through the things that we talked about today, but just in a lot more detail. If you want to keep up with NativeScript, you could follow our Twitter handle @NativeScript. You can come to our workshop tomorrow. Jen and I will be giving a 2-hour deep dive into NativeScript. We might even wear our aprons again, so it'll be pretty amazing. You should check that out. And finally, if you have any questions, feel free to reach out to us. We'll be around for the full event. You could come find us at the Telerik booth. You can reach out to us on Twitter. So just let us know.
Thank you so much. It's a pleasure.